Okay, so let's take a look here. Hopefully you did well and kind of able to figure this out. So we remembered that we had this divided into 6 triangles. So each of these angles was 60 degrees, 360 divided by 6. And then split in half, each of these was 30 degrees. So what was angle 2? Remembering that an apothem here, which is pictured, they use the title apothem, which means that it comes in at a 90-degree angle. So we could either say that we had up here, 60 degrees up here, and we have an isosceles triangle, making each one of these 60. Or we could look at the smaller triangle, the smaller right triangle, and we could say that we have 30 up here, 90 down here. So 30 and 90, that's 120. That leaves us 60 to get to 180 by the triangle angle sum theorem. So that makes this 60. So angle 2 is equal to 60 degrees. So either way you do this, but you're going to want to get some practice just moving your way around these triangles and figuring out what each one is made of and what each piece is that you're going to be able to develop here. Because what we're going to do is we're going to be finding the area of each of these triangles. So, all right, let's go ahead and do that. All right, everybody, let's go ahead and start working on area. So I've got a couple of yellow boxes here, but this one is kind of a little bit of a postulate that just sort of, it's going to help us to kind of come to terms with what we're doing here. So the postulate says here that if two figures are congruent, then their areas are equal, which makes sense, right? If you can take one and put it on top of the other and they're exactly the same, then the space that's contained between each one is going to be the same. So what we're going to do is we're going to be looking at, remember, all these triangles that compose up a regular polygon, right? So we're going to be looking at these triangles, and if we find the area of one, we can just multiply it by the number of sides of the polygon, which is going to be the number of triangles. And that's really what's going to happen here, okay? Here's our formula for the area of a regular polygon. So the area is going to be equal to 1/2 apothem times perimeter. Okay, so what we're going to be doing here is we're going to take the apothem. Okay, think about the area of a triangle. The area equals 1/2 base times height. That's really what we're doing here. We're finding 1/2 base times height, okay, for each of these triangles. But instead of saying apothem, instead of saying height, we're saying apothem, and instead of base, we're saying perimeter. So instead of the base of each individual triangle, we're going to give the whole perimeter, which of course is going to be that base times the number of sides. Okay, so having perimeter instead of base is going to be what gives us the entire, all of the areas put together instead of just the one. Okay, so think of it as area equals 1/2, really height times base. Let me draw it in the same order it is with there, height times base, because height is the apothem. You should know that now. The apothem goes from the vertex down to the opposite side, meets it at a right angle. So the height is the apothem, and the perimeter is going to be all of our bases put together, basically distributing this area around the entire figure. So what we're going to do then is look at this in terms of our formula now and find the area of a regular polygon. Okay, so let's take a look at a problem that is a little bit more straightforward. So here we go with area equals 1/2 apothem times perimeter. So 1/2 apothem times perimeter. So we need two things. We need the apothem, we need the perimeter. Well, this problem is nice because they give us the apothem, okay? And they just about give us the perimeter, right? They give us 12 centimeters there. So how many sides are there here? 1, 2, 3, 4, 5, 6, 7, 8 sides. So our perimeter is going to be a distance all the way around. So 12, 12, 12, 12, 12, 12, 12. So it's going to be 12 times 8, right? So 12 times 8 is 98. So we've got area equals 1/2 of apothem 14.5 times 98. So area equals, so we get out our calculator, which I don't have loaded up here. Let me get that loaded up. So we got our calculator and we type in 14.5 times 98 equals 1,421. Then we're going to take that and divide that in half. And we're going to get 710.5. So 710.5 centimeters squared. Remember, again, it's little squares here. Okay, so it's very nice. You can plug this into a formula if you have the apothem and the perimeter. So you're saying, Mr. Chapman, why'd you talk about all the triangles and everything? Because, of course, it's not always going to be so simple as just getting the apothem and the perimeter. They're going to throw some curveballs at you, okay, and not give you the apothem or the perimeter, and you're going to have to use these triangles to figure out what you need. So let's take a look at that. Okay, so let's take a look and see something where this is all you got. You got 2 bits of information here. You got the fact that this is a regular polygon, and you got 1 side length. Okay, now what you've got to do is you've got to figure out how to use this to get the whole formula here. A equals 1/2 apothem times perimeter. How are we going to get everything we need there? Now you can probably look and see that between apothem and perimeter, there is 1 that we can pretty much put together, right? If you take a look at this, we can put together perimeter, right? We've got 6 sides here, right? 1, 2, 3, it's regular, so they're all the same. 1, 2, 3, 4, 5, 6. 12 inches per side, so 6 times 12. So we know we've got a perimeter of 12 times 6, 72 inches. All right, so all we're going to need here is an apothem, all right? So got to put in your center there, and let's draw ourselves our little triangles. Our cute little triangles. Bob Ross was this guy who used to do painting shows. We talked about putting cute little cloud over here and a fluffy little this and that. We're putting in cute little triangles here. Okay, so we got our 6 triangles, right? And we've got our 12 inches there. So let's take ourselves an apothem here. This is what we want, right? We want this apothem. That's what we want the distance of. Once we've got that, we've got everything we need for our formula. So how are we going to go about getting that? Well, first of all, remember that we've got this apothem is going to break this into 2 equal parts. So we've got 6 inches over here, we've got 6 inches over here, right? So we got those 2. So what else do we have? Well, maybe we could figure out what the radius is and use the Pythagorean theorem, but we're not sure if we can do that. So what can we do? Well, let's see about filling in some of these angles here. Remember how we filled in angle 1, 2, and 3 in the last video? Let's fill those in. So we've got 1, 2, 3, 4, 5, 6. So this is actually the same thing with 6-sided figure. So we have 360 divided by 6. So that's going to make each of these 60 degrees, which means we've got 30, 30 right here, which means again we've got 60 right here, and we've got our 90 degrees. So we've got 30, 60, 90 right triangle, right? So we actually don't need to do the Pythagorean theorem and all that. We could use the form of a 30, 60, 90 triangle, right? So think back to the last chapter when we did the special right triangles. Yellow boxes, don't fail me now. We had our 30-degree angle, our 60-degree angle, and our 90-degree angle. And remember what the form was. We had S opposite the 30. We had S times the square root of 3 opposite the 60, and the hypotenuse was 2 times S, right? So we've got here our 30, 60, 90 triangle. So what do we know? We know what S is. S is 6 inches. So we've got 6 in for S. So what do we need? We need the apothem. Which one's the apothem? S times square root of 3. So our apothem is going to be 6 times the square root of 3. Okay, so now you've got the apothem, you've got the perimeter. So go ahead and tell me what the area is, and you're either going to have 2 ways to do this. Either they're going to say, I'll put it in simplest radical form, or to the nearest tenth. I'm going to have you go to the nearest tenth. All right, good luck, and we'll go over it in the next one.